We'll go ahead and get started. Welcome, everyone. I am Louisa Emmons at the National Center for Atmospheric Research. And today we're going to go through how to actually run MUSICA on the Cheyenne supercomputer, or perhaps on your own computer. And Simone Tilmes will be going through the slides. So what we're going to do is Simone has several slides, and for about 20 minutes, she's just going to go through the procedure of how to run the model so that you can just see what all the steps are, and without really leaving you time to do it yourself. And then we'll go back and go through it slowly and let people follow along and actually run the model if they want to. So I'll hand it over to Simone.
Okay, welcome everybody. I'm Simone Tilmes. I'm also at ACOM at NCAR, and as Louisa said, today we'll go to our second set of the tutorial, which is running MUSICA version 0. And so first of all, if I can advance. Yeah. Okay, so I want to give a little background on our MUSICA version 0 CONUS community simulations. These are in principle production runs that we have performed of a regional refined model run over the contiguous US using MUSICA version 0 for 2 years. And the idea is that we wanted to provide model output for the users to look at their specific scientific questions. However, since there's quite a variety of what people want to do and want to look at, we thought it makes more sense to give you, the users, the opportunity to actually run this model simulation and customize it yourself. So we defined a specific, what is called component sets and data sets that makes it really easy for the users to reproduce our simulations and then also to extend or modify the model simulations. And we do also post the output that we have produced on, for easy analysis. But this is what this tutorial is about, is for you to learn how to run those simulations in almost the same way, or in exactly the same way as we have done, and then modify them for your needs. So in this tutorial, we first go through an introduction of these MUSICA version 0 CONUS community simulations. And I will describe what are they, what is different to a normal release version of running CONUS, and what are the configuration updates and default settings. And then you learn how to just set up this model run out of the box without any changes. And then we go into more details and in how you can modify the setup for your needs. And finally, we'll also talk about modifying output and emissions a little bit more advanced. But we want to also point you to into the right direction, because we can only cover so much in 1 hour, and hopefully you can get the right start at least for doing what you want to do. So just stepping back 1 minute, MUSICA version 0 is really the CESM, the Community Earth System model that runs with either ChemChem or the whole atmospheric model WEChem with regional refinement, as shown here. So basically, CESM is can be a fully coupled Earth system model with various components. Obviously, the atmosphere here with the simple chem version, the atmospheric version without chemistry, the ChemChem version that we're working on today with, which is also a low top version going to 40 kilometers and with 32 vertical levels. And then the whole atmosphere community version that goes much higher up to 140 or 50 kilometers. And we even have a much higher version. But MUSICA so far with regional refinement has not been run as a fully coupled model. So we're staying on a configuration where the model is coupled to the land, which is always the case. The atmosphere is coupled to the land. Well, we'll prescribe sea surface temperature, sea ice, and other components. So ChemChem, WEChem is obviously a very complicated setup with various processes included, and this is just sketched here in the slide. And just to again clarify that while we are coupling to the land, it is really important in any configuration because many processes depend on the land, wet deposition, dry deposition, emissions, radiation clouds, and so on. And especially for the emissions, like the biogenic emissions, we do run those interactive with the atmosphere. So thinking about a regionally refined grid, we need to make sure that our land model also has a regional refined grid. So we do get the emissions on the same scales as we have the atmosphere. And so, yeah, as I said before, WECM and ChemChem, I don't need to just, are comprehensive Earth system models, and we have set up a component set that really reproduces, makes it easy for the community to use this. Since it's so complicated, we're putting all the settings we think are necessary for having a scientific and validated version for you together. And so we also run this configuration with with meteorological analysis, and I will go through this in the following slides. So the component sets, or we call them Compsets, are available for MUSICA. And in general, you do, actually, this is option 1 and option 2, not just 2 ones, sorry. The bottom option to run MUSICA is to just take the release version, and that you can do outside Cheyenne or on Cheyenne, and download your model code and set up a Compset that is called FC Nudge, which means F is for the fixed ocean and sea ice components, and the C is for the chemistry. And we're nudging to the met fields, as I said before. But as I said today, we want to teach you the specific setup of our community runs. And so we created a new Compset that is called the FC CO tags nudge. And the difference here is the CO tags, because in this simulation, we also added specifics that you can run with CO tags or tracers within this model version. And so we'll go through the modifications, and also what you don't have to do in this tutorial, if you run it right now, is to download the code, because we have it already in basically a sandbox. However, what we plan to do in future releases is to put this Compset also out there for people that don't run on Cheyenne, but outside. So yeah, today we don't need to download a source code if you are on Cheyenne. If you are not, you can still follow the tutorial, but you won't get the exact same settings. So for what is now changed in our new Compset for these community runs, and so we are starting with the CESM 2.2 release code base. And for the chemistry mechanism, we are using the TS1 Compset, TS1 chemical mechanism, that is for the troposphere and the stratosphere. But we added some things, as I said before, we added CO tags, we added some bug fixes. And if you want to know more, you can go to the wiki page that I will point you in the end of this talk. And there is some way also for the land model, we added some code fixes in those community simulations that are purely there for writing more outputs. However, this is currently not in this specific version, but it will be in a future release version. So if you're interested in that, you can learn how to do that as well. We did make sure that our lightning production is in line on what we expect from observations as well as the dust. So we added some tuning that wasn't in the release version. Also, for this configuration, we do want to give the users the opportunity to run beyond 2014. All the default configurations usually use CMIP 6 emissions that end at the end of 2014, but often we are interested in recent field campaigns that are afterwards. So we decided to put we call it lower boundary conditions. So the model runs with surface prescribed concentrations of greenhouse gases and chlorofluorocarbons. And we're using the SSP 8.5 future scenario after 2014, so we can continue running in the future. Of course, the users can change that to other boundary conditions if they desire. So we can talk about that later. And so, as I said before, we're running with meteorological nudging. Again, I will talk about that in the next slide. And we change a nudging coefficient different from the default setup. We do have anthropogenic emissions available that were already interpolated for the CONUS grid. And those are right now as a default is our CAMS version 5.1. And those are set up for the year 2000 to 2021 right now. They are available for the users to use. We do have biomass burning emissions, and we're using the QFED emissions that are available from 2010 to 2020. And we also use a so-called online air-sea surface for soluble species, or ACES, ocean emissions. These are interactive ocean emissions, and we're using DMS here that are using a machine learning implementation. And we have updated updates to the sea surface temperatures. The release version is just going to 2016, but you do want to run consistent with sea surface temperatures from observations. We use the Hadley climatology until, oh, not climatology, but time series until 2021 now. So for our default runs also, as I said, we decided to start in 2012. And we could have run different years, but that was something we thought they are already interesting field campaigns to compare to in 2012 and 2013. This model run starts from initial conditions based on a spin-up that has been run on a lower resolution, which is a 1 degree configuration of the whole globe, so not regional refined. We started the spin-up simulation in 2010 and ran it all the way to 2021 as well. So this spin-up simulation gives us different initial conditions that we can start our model run, and we can interpolate to our model configurations, as has been done for this community runs in 2012 as well. We decided on output that we thought is useful for us in the community. Again, we can change that. You can change it in your runs, and this includes, so first of all, monthly runs, monthly output. So every month we get one output field that is looking like a case name and then H0 file. And this output was setting towards interpolating to a regular grid, which makes it really nice for a quick look without having to deal with the irregular grid, which is the case for our regional refinement. And we have talked about the grid much more in the previous tutorial. If you have more questions to that, yeah, I want to refer you to that. But so we have a regional grid as the first output, and then we do a second output, which is also a monthly output, but on the regional refined native grid for you to really look at the details if you're interested. And then we produce daily files on the native grid. We did produce 6 hourly files, which are interpolated also to the 1 degree grid. And that is because those can be used for both WRF boundary conditions. So if you do want to compare the CONUS run, this one, with a WRF run, and you want to run WRF with exactly the same settings, you can do this with these boundary conditions. And finally, we also added some hourly data. As a note, you know, you want to be careful on the output, because there's always a lot of output will fill up your archive in your disk very quickly. So just as a note. In terms of nudging, yeah, as I said, or I haven't said that maybe, the model is producing its own meteorology. It runs the physics and always produces its own meteorology. But if we do want to get a situation where we can compare to aircraft campaigns, we want to be as closely to observed winds as possible. So we are nudging our winds and temperatures. And here we are using the mirror to meteorological analysis. For this model configuration, the first thing we have to do is take those native mirror data that come on, I think, on a 0.1 degree grids, or maybe a quarter degree, I think a quarter degree, sorry, and then interpolate them to the specific model grid. So it's Kim grid has the 32 levels, and then we also have the regional refinement. And we already interpolated those data for you. They are mostly available already between 2012 and August 2021. We'll talk a little bit about the nudging. How much do we actually nudge the model towards those data? Right now we're using 10%. because that was identified to be the most optimal way to do that without introducing too many errors. And there's more about nudging, or if you need to change something, you can look at this wiki page that is listed down here. Now we're getting to the fun part, to set up the model run. And as Louisa already mentioned, it may be good you don't just start on it, but you listen while we go through it, and then you do it, and then we can go through what your specific needs are for the setup. But really, once we have created this component set for you, it's very easy to just reproduce the run in basically 3 steps. And actually, I think in our PowerPoints on the website, we have not 1, 1, 1 here. We have 1, 2, 3. Something went wrong with this presentation. So first, while I was downloading it, but I hope that's okay. First, we create our new case, and that will land in our case directory. So what we do is we go to where the current code is located, which is the sandbox, which was derived by Francis Sweat. So we can go to this location and then create our case with really only 1 line of a command. And Louisa will post, or has already posted, the PDF of this presentation, which hopefully has the right numbering in it. So you can just copy paste this whole line, but you have to do some changes for the create case. Here's the project number. Running on Cheyenne, you should know your project number, or we can help you how to find that. And then you have to change, obviously, where you want to have your case directory. So that's usually in your home or in a work directory, and you can give your case some name. And since we still have not, this is not a release version, you still have to add this behind the --run -unsupported. If there are questions in the chat, let me know and interrupt me. That's all fine. I'll just keep going, if that's okay. So the second thing is then, once you created your case, you go to your case directory, CD there, and then you actually set up your run. 1 command. It's case setup. And then the second command to build the run is case build. But this is a way to do this interactively and not directly on Cheyenne. Sometimes there's too much processing available that this command crushes. So what we recommend is actually using a command that is called QCMD with your project number and run the build. And once this is done, you just submit your case. And basically, this gives you your first model run that will run as a default 5 days, basically out of the box, and create the output for 5 days, as we have said. To check your run, am I actually running? What happened now? You can look at this command qstat, which gives you the status of your run. -u is for your user. So you put in whatever your username on Cheyenne is, and you should get the status of your run. And I haven't put that, but we'll go through it during the test, and you can see what is happening there. You can also, maybe by accident, you submitted 2 cases, or you wanted to do something else, you can delete your run. And when you do a qstat, you find your run number. We'll show that to you during the, when we run the tutorial, when we practically do this, how to delete the run as well. Once you set up your model run, you can go to your so-called run directory. This is where you keep track of everything that is happening. The model is running, it produces log files, it produces output, and you can already look at it, which we will do during the tutorial. And once the run is finished, all of this, what is needed and wants to be kept, will go into your archive directory, which both the run directory is in your Glade stretch, your username run. Actually, I forgot, here you need to put your case name. And second, here it says you need to put your case name. So it is Glade stretch, your username, archive, and then your case name. We'll correct this in the final slide. So we'll post. And so then we can look at the output, as you can see here. More information can be always found at the wiki page. So you can read up on it in much more detail. The next thing is to modify our start dates or the year or other things. So what we'll start is here is changing your start date and the length of your run. And when you're running outside the run side that we have already run between January 2012 to December 2013, you do, as I said before, need to create a new initial condition file from our spin-up run. And we also need to get a new land initial condition files that are already available. So what we're going to do is we'll go through the process of actually regridding this initial condition files for the specific year and months you want to run. And then checking your run, we'll go through that, and also changing it. So we can change various things that are possible, but we also need to check that we have variables set to the, for instance, if you do want to run, say, before 2000, or a bit outside the range of available emissions, you need to make sure that you change that. So modifying the start date is the first thing. How do we control the run? After our three first basic components, to run it, you get a 5-day simulation. But you do want to modify the run, and there's one very useful file that does control your run, which is called the environment run.xml file, and that's in your case directory. And here you can change the start dates, the duration of the run, research files, and other things. Another important file that I want to mention, we're probably not going to touch it, is actually the job queue that you're running on and the wall clock time. So a maximum of a run length is 12 hours on Cheyenne, and that's the default in your wall clock time. You can change that if you're just doing test runs, say, to 1 hour. That will get you much faster into the job queue. When we submit our run, we're entering a queue. And if there are other runs ahead of time, you have to wait a bit of time. Sometimes you really want to do something quick and just have a really quick test run for a day. You may want to change your queue to premium and your wall clock time just to 1 hour to test something. But then when you do a production run, you want to run either on regular or on economy. And this is because the cost of the model depends on this queue setting. Premium is 1.5 times more expensive. Regular is just the normal cost, and economy is, I think, 70% or something. So you can run cheaper, and if you do some production runs that way. So how do we change the start date? There are the so-called XML change commands that make it really easy to change things in, for instance, your environmental run XML file. So you just have to write those XML change. This is a setting in your environmental run XML file, and you change it to your run start. Say today you want to test the year April 2015. For your start date, you would put in 2015 0401. So that would be your start date if you want to change it that way, or whatever you want to run. Say what is your interest, right? Your stop option also is, we do not only want to run for 5 days usually. So maybe you want to change that to either end days and months, or even in years, which is probably not a good idea initially for an expensive Conus run. You can say end days and then change your stop option, say, to 31 days, which is 1 month, or you can say 1 month and put this in. Also, it is recommended to change your restart options, especially when you run a run that is very slow. Say you run 30 days, you could put in restart options that are a fraction of that. For instance, 5 days. So every 5 days you get a restart file in case your model run stops in between for some reason. When you have started your model run for already 5 days, you can also use an option that is the continue run, which will just continue where you stopped. But for that, you do need your restart files available. That's why you may want to think about that. And I'm happy to answer more questions on that, obviously, later. So once we say we want to run now a certain year, say somewhere after 2012 or 13, say 2015 or what, we do need to interpolate our initial condition file. And we do have a GitHub repository, which is the IPT, the input processing tool depository, where you can download it very easily on GitHub. And there are other things included in this, but one is how to modify initial condition files. And you can actually download here an NCL file. This NCL file is already made for the Conus grid. So we put in some directories and source directories. That is something that the model will use the right resolution. But what you have to do is to modify that to actually specify where do you want to write that file and what is the name of the file. Because you don't want to just write it in a normal directory or in a standard directory because it's yours that you want to use for your run. Also for the source directory, so the spinout run is located here, the initial condition files, and you want to make sure you put the right start date in for that month and year that you want to run. One other thing that is a little bit a complication is that for some reason, these programs don't write the right format that is needed for an initial condition file on Cheyenne. And so you do also have to apply a command to change it to a different format, to the CDF5 format. So you have to run this last command as well. If you not do that, you probably get a crash of your run. So now we have our new initial condition file. And how do we let the model know how to use it? And we do this in modifying, which is called the user NLCam file, and also later the user NACLM file. So this is the name list files that define specifics of the model run for the atmosphere and also for the land. So for the atmosphere, in order to add our new initial condition file, we added our user NLCam file, and initially it is empty. And if you want to add something, you just add this line, and then it will use, which we call the NC data file, which is the initial condition file for the atmosphere. So as I said before, well, if you do want to run outside this range that we have run, 2012 to January 2014, you will have to go to this interpolation. But if you don't, you can also use an initial condition file that we have produced through our community run, which is located at this place. So for the land now, we'll go, just looking at the time. We just choose a land initial condition file. So either again, we can use the file that we have created for 2012 or 13, which is, you know, matching your times. But if it is not the right year, so say you want to run 2015, you still can use one of those initial condition files, because what is really important is more the season than the year for the land. The land we use for the biogenic emissions, it's more like a climatology. However, we want to have the right settings that the land, for example, in winter actually has snow, and in high latitudes, while in summer it may not have, and it has different settings. So that is possible and shouldn't impact the run too much. There is one option: if you do use a different year for the land file that the model doesn't crash, you need to add in this name list for the land, use init interpolate equals true. And for the land, you do have a different command. It's not NC data, but here it's finidat. So next is we'll want to modify and check our setup. Now we changed our user NL files. And in order to execute that, you can run a command, which is called preview name lists. And then you can actually check if you have gotten this new file in, and also you can check what other name list variables are available. And as you do in this you go in your case directory, there is a directory which is called case docs. There is a file that's called ATMN. This is the name list for the atmosphere. And there, if you look through, you find your NC data file, and hopefully it's the one that you want that you just changed. But you can also find other things that I mentioned before. This is the lower boundary condition file. And as I said, we use the SSP 8.5, but if you desire a different one, you can change that. And same with the nudging variables. You need to make sure that when you run, that you're actually in the range of what is set as a default. It should be all fine when you're staying between 2010 and 2020 of any of the model runs, but you should maybe check anyways, as well as the nudging coefficients, as I said before. They can also be changed to tighter nudging or more loose nudging if you think you want to do that. You also can check your emissions. We do have surface emissions, which is called surf image specifier, and also vertical emissions, which are called external forcing specifier. And finally, the model output can be changed. So we're defining our model output in so-called Finkel variables. And you can see your Finkel variable in the model run, and you see a list of variables that will be output. And you can define, obviously, what output string you want to put what variable. So there are different ways to identify it. As I said before, our default setting is that we are first outputting a monthly variable on a interpolated grid and the finite volume grid. So the Finkel one, the number 1 means you get 1 output per file, 1 timestamp, so 1 month per file. And the frequency 0 always means that it's a monthly output. And the interpolate output here to true means we do interpolate to the regular grid. There are more settings on what the grid should look like, so you could even modify that to ½ degree to a ¼ degree if you wanted to. The second one was the monthly output, but not interpolated, so it's a native grid. The third one is the Finkel 3, is a daily output file, daily average. And so the minus in front of the number always means number of hours that you want to output. Here we have the daily, we also have the 6 hourly, and then we have an hourly output. If you do want time steps, you just have to do simple numbers without the minus, and you get a time step output. So now one thing is that we set up our new run from a different start date. But the other thing is we either want to start basically from an existing run, like we have performed all the runs for 2012 and 13, and say you want to run 2012 April. You don't need to set up the run. Actually, it is much better to run a branch run exactly from our run and continue it and maybe add some modifications to it. So to set up a branch run, it's different from the default, which is basically a startup. A branch run means you're using really the exact setup where you stopped and continue. So you should get the same answer in your branch run if you don't change anything else. And for that, we may go, some people on this tutorial want to do this instead of setting up a startup run. In that case, we will go again to set up our case in the case directory as we had described on slide 8. We'll go through that later. But then instead of running a startup run, you will have to change your run to a branch run. And this is again changing the environmental run XML variable, as you can see here. And now your run type is not startup, but branch. But you have to identify from what run you actually want to start, because the model needs to find all these input variables to continue the run. And so your run ref case in this case here for the community runs is our run that we performed. So you need to put that name in here. And then you can add your ref date, which can be, you know, going from anywhere between 2012 or 13, or if you have already done a 2015 run, you can also branch, you know, from that case that you already done and start there. So you do a normal setup of your run, but before you build your run, you do have to copy those files, which are restart files that go into your output. And we'll go through this during our tutorial when we do hands-on. More, those restart files from our community run have to be copied in your run directory. Then you can build and you can start your run as described on slide 8. So this is basically what we want to go through today, of different options to modify your run. And as I already said, for you, we have already most of the meteorological data are interpolated to the CONUS grid for 2012 to 2020. Sorry, wait, now I'm getting. So you can find them at this location. You might want to check before you do your run that that's actually the case. Also, if you need to process new years coming up, for instance, after 2020, August, you do need to interpolate more data. There is information on the wiki site here. And also, if you want to change to different emissions, there are ways to interpolate those to the CONUS grid as described on our MUSICA wiki. And also there's more on inventory of emissions on the ChemChem wiki. Also, one thing I want to point out, after you ran your run and you have your output, obviously you want to plot it. And I want to refer you, if you haven't attended it, to the first MUSICA tutorial that happened in November. And that really nicely describes how you can look at the data. Another thing is that you can do some post-processing with your model runs and putting them on time series. Basically, the output will be one file per species. And that is how we're actually saving our community output right now on the Dash repository. If you're interested in post-processing your run, there's also information available. We're not going to go through this today. As I said, the output of the current simulations is available. You can find more information on the previous tutorial. This is a slide from the previous tutorial. So you can go to the Dash repository, which is actually now called the Geoscience Data Exchange. And finally, here are some more resources. Again, this may be good. You can look at this. You can learn much more than going way beyond what I said and do more modifications. And here are some upcoming events that I want to mention for you. We do have another MUSICA tutorial, and this goes into the detail how you actually create a new variable resolution grid. That's on January 14th. We also invite everybody to join our winter working group meeting, which will happen from February 7th to 11th. And this will get you much more details also on the CESM progress, on developments and other things and science. So it's a lot of fun. And we do have another MUSICA tutorial coming up on February 11th, which will then talk about a model evaluation package and post-processing package. So that will be coming up. There's another slide in this deck on how to download your MUSICA source code. We're not going to do this right now. As I said, if you have an account on Cheyenne, it will be nice to not download it, but use our sandbox. And with this, I will start for now. And first of all, open up for questions. Thank you. Are there any questions that come up or came up?
Yes, thank you, Simone. So there was a question about the cost, which I answered in the chat. And CONUS grid is very expensive. It's quite a few times more expensive than regular ChemChem. Then we have a question about what is the best practice about interpolation during runtime? Does it slow down the model? Should we use bilinear interpolation? So I think that was related to the saving the output, that you can save the output as interpolated. And I don't think we have any choices of how it's interpolated. It's, I think it's just a bilinear horizontal interpolation.
Right, yeah, so it is true that it costs more time and to write out more output. So I'll keep that in mind, not only this phase. And it is true that we cannot, I think it is just a bilinear interpolation, I agree. So that's why it's good to, if you really want more conservative interpolation, you can just write out your native grid variables and do your own interpolation. But it is sometimes very nice to do a bilinear interpolation for checking, since it is okay for concentrations to look at that in that way. Other things may be messed up, like if you look at lightning knocks, for example, or some burdens, you may not get the same answers if you do a linear interpolation or conservative interpolation.
Right. Yeah. So yeah, it's not useful for like checking the emissions. That's not good to do. Another question, does branch run require restart files too? What is the difference between a branch run and a restart run?
Basically, it is the same. A branch requires restart runs. So you basically, well, there's two things. Maybe what I would say is there's a branch run or there's a continuation of your run. So there are two things, right? You run your model, you end up after 1 month and you want to continue. You do have restart files that allow you to continue your run. As I said before, you only have 12 hours, so you can only run so far, and then you continue your run. But if you say, I want to branch and change something, or I want to branch off from an existing run, then you also need all the restart files in your run directory, but then you can do changes to the model. And I guess we always need restart files to do that. There is another thing that I did not mention. There are hybrid runs as well. They do also require restart files, but they will not give you the same answers. They will not, I think they start from the same ocean state, but it will be a little different in the atmosphere. So you do need to make sure that if you want the exact same run, you do a branch. Does that answer it?
I think so. Jan already said that makes sense. So that's, yes.
Good.
Or Jan, yeah. Armin asks, can we adjust emissions? Do we have access to the anthropogenic emission files? So do you want to modify existing emission files? You can easily specify in the user NLCam different emission files. So we often do that. There are multiple choices of inventories. If you want to unmute yourself and clarify your question, you're welcome to. Oh, modify the existing files. Well, yes, you're free to do that. You'll have to copy them to your own directory and modify them how you want. And then you'll have to change your user NLCam file to point to the files that you've modified.
So yeah, that's correct. I'll just see in the next question already.
Yes. So yeah. Okay, good. Chinyi, if I need to change the chemical mechanism, does it mean that I can only use hybrid run?
No, it doesn't mean that. You can change your chemical mechanism and do a restart file, a branch run. So because all you do is basically inside the model, you change something, but you don't change basically, yeah. So it's possible to just do that. I don't know what else to say there.
Right. So you have to rebuild the model. If you change the chemistry, you
Yes.
have to rebuild the model. So you have a new executable, but then you can use, then you can do a branch run because you might want to save different output. You can't just do a restart run if you want different output. So probably a branch run would be the best choice with that.
Yeah, it's always a good idea to do a new setup, to set up a new run. If I have this run, that's my baseline, right? And then I change my chemistry. You give it a new name and you change your chemistry, which is described in the wiki page really nicely for wiki. We don't go through this now. And then you set up your run again, and then you can do it like a branch run, like I described in this slide. Then it should work fine. Yeah, I wouldn't, whenever you do something new, I would set up a new run so you can really compare those differences.
Yeah, new case. Make a new case. Make sure you're clear on what.
Yeah.
There. Are there any other questions at the moment?
So I guess we have time to start. I have a question for you. So who is interested? First of all, who is not running on Cheyenne right now? Is there anybody that is not able to run on Cheyenne? Raise your